Consider the differential equation dy over dx is equal to ky times 10 minus y. We want to use Euler's method with two steps of equal size to approximate f of 2 in terms of k. Now, y equals f of x is going to be the particular solution, and the initial condition is y of 0 is equal to 1. This is Euler's method here. We need y sub n is equal to y sub n minus 1 plus h times f of x minus n minus 1 comma y sub n minus 1. H is going to be the step size, so we want to approximate f of 2. We start at 0 and we want 2 steps to get a 2, so clearly each step size has to be 1. So here h is 1. Now when I'm looking at y sub 1, that's going to be y sub 0 plus f of x0 comma y0. y0 is going to be the initial condition. This 0 is x0 and this 1 is y0. So y of 0 is 1. And now for f of 0, 1, we know that f of xy is equal to dy over dx, which is ky times 10 minus y. So if I'm looking at f of 0, 1, I'm going to plug in 1 for y, and there is no k, there's no x here, and so we get 9k. Now add 9k to 1 to get 1 plus 9k as y sub 1. For y sub 2, it's y sub 1 plus f of x1 y1. y1 is what we just solved for. That was a 1 plus 9k. x1, now x1 is going to be 1. So basically, you start off at x0, you go to x1, and then x2. Okay, so this is the intermediate step before we go to x2. Okay, so then 1 plus 9k, well, f of 1 comma 1 plus 9k, we have to plug in y equals 1 plus 9k into this equation. And then simplifying, we get negative 81k cubed plus 81k squared plus 10k plus 1. And so this is the value, or this is a solution at x equals 2 in terms of k. Now we want to find f double prime of 0 in terms of k and y. So recall that dy over dx is equal to f of xy, which dy dx is ky times 10 minus y. Now we're going to take the derivative of this. So you have to apply the product rule. The derivative of ky is k times dy over dx multiplied by 10 minus y minus, so here I did a minus because the derivative of 10 minus y is negative dy over dx, and then multiply that by ky. Recall that dy over dx is given to us as ky times 10 minus y. And now we simplify, so k times ky is k squared y. I have 10 minus y times 10 minus y is 10 minus y squared. And then ky times ky again is k squared y squared. Here I have a negative and a 10 minus y. I distributed the negative to get y minus 10. At this point, I can factor out a k squared y and a 10 minus y, and what I'm left with is 10 minus y from over here, and then a plus y from over here. Now the y's are going to cancel, and then this 10 I just pull out in front. So it's 10 k squared y times 10 minus y, which I'm going to break it up as 10k times ky times 10 minus y, because this thing is dy over dx. And the reason I did this is because now it's a lot easier to take the derivative of this. Since we're looking for the second derivative, So the derivative of dy over dx is d squared y over dx squared, which d squared y is just the derivative of ky times 10 minus y, which we borrowed from the previous slide. And now we just do 10 times 10 is 100. K times k squared is k cubed. And we plugged in 0 to get 100k cubed y times 10 minus y as our final answer.